Well, welcome to Chapter 3. This is 3.1. And in 3.1, we're going to add and subtract integers and fractions. So the most important thing I think about adding and subtracting is a fact that you cannot add or subtract units that are not alike. And recall from Chapter 2, right? 3 cats plus 2 dogs. You can't add them unless you change the unit to something like pets. So in fractions, that's going to become really important. So here we're going to look at an illustration of the commutative property. Commutative. And commute, think about it as moving, right? Commuting, moving. So you can move around and add in any way that you want. The order is not important. That's good with addition. So I'm going to add these golf scores up. And I'm going to do it using the commutative property. So I'm going to go 5 plus 5, there's 10. 7 plus 3, there's another 10. 5 plus 5, there's another 10. 6 plus 4, there's another 10. And 5 is the last one. So it's 10, 20, 30, 45. And this one, I got 6 and 4. There's 1, 10. Add these next. 20, 30, 44. So those are the golf scores. And I added them up using the commutative property as an illustration of it. Now, importantly, this 5 and this 6 are the same unit. That's 5 strokes. You have to hit the ball 5 times to get in the hole. This, you had to hit the ball 6 times, right? Now, importantly, this is a stroke. This is money. There's fish and there's carrots. Now, I can't add money and carrots, and I can't add fish and money, and I can't add golf strokes and carrots, right? You can only add strokes and strokes. So importantly, all these things, all these numbers are strokes. That's what it is. So we're going to be working a lot with integers in this section, and there, to refresh your mind, is a definition of integers, right? Positive and negative whole numbers. So it says you spend $4 on lottery tickets. Just how to use the number line here to get started with integers. So I spent $4. I start at 0, and I'm going to go to a negative 4. One of the tickets was a $2 winner. So I'm going to go from where I am, negative 4, and go back 2. So I go to the left for negatives and to the right for positives. What was the net spending? Well, I wound up at negative 2. So is subtraction commutative? Well, let's look at that. Just take something like 6 minus 2. That's 4. Is 2 minus 6 equal to 4? And the answer is no. That would be a negative 4. So no, subtraction is not commutative. I think that the way to look at these different numbers, these different addition and subtraction problems involving negative numbers, is to recognize here there's 2 distinct numbers. And this is a negative 7 and this is a positive 2. So I'm going to start here at the negative 7. Start at 0 and go down to a negative 7. And then I'm going to go back 2 the other way, adding 2. So that would be a negative 5, which makes sense. You lose $7 and you paid them back 2. You gave somebody $7, you borrowed it and paid them back 2. That would be, you still owe them 5. You borrowed $3 on Monday, Tuesday, and Wednesday from your sister. How much do you owe her? Well, look, you got 3 numbers. A negative 3, another negative 3, and another negative 3. And in life, you have to add up your losses. So the answer is going to be you owe her $9, which is a negative 9. Now let's use the number line to do it. So I go negative 3, negative 3 more, negative 6, negative 3 more, negative 9. Now this is a little different here. This is 5, take away a negative. Taking away a negative is the same as adding. So when you see two negative numbers right next to each other, you can go like that and put a plus sign. And the answer is 9. From the reading, adding a negative number is equivalent to subtracting a positive number. In other words, 3 plus a negative 2 is the same thing as 3 minus 2. And we think about it this way, although most of the time we write it this way, but it's the same thing. Taking 3 and adding a negative 2 is the same. And there's some advantages to that. And the main one is, if you think about subtraction as addition of negatives, then you're adding and you can use the commutative property. So here I can first I want to change this double negative to a positive 6, right? You can first, and I'm going to add up all the positive numbers. So there's a positive number, and there's a positive number, and there's a positive number. So I'm going to have 4 plus 5 plus 6, which is 15. And then you can add up all the negative numbers. And here I have a negative 2 and a negative 3, which would give me lose $2 and lose 3 more. I get a negative 5. And now finally I can put these together. So if you have 15 of something and you take 5 away, you have 10. So that would be the answer. So it makes it a lot easier than trying to keep in your head all the different, negative 2 plus 4 is 2, 2, right? Just add up the positive, add up the negatives, and then finally get your answer. And here's another example. I only have $3 that are the positive numbers. The negatives, I have negative 2, negative 2, negative 2. That would be a negative 6. I don't have 3 positives. I'm going to add to that a negative 6. Or you could just say that's 3 minus 6. That's a negative 6, but you're adding 3, so the answer would be a negative 3. So, in other words, seeing this here as this here with positive plus signs allows you to think and use the commutative property. So here are just some key facts that I'm sure you already know, but just to refresh your mind about these key facts, you might want to pay particular attention to, because we're going to use these ideas a lot. We kind of already know them, right? Adding, subtracting the same number, like here, 3 plus 2 minus 2, results in no change. Adding 0 to a number results in no change. Adding a negative number is equivalent to subtracting a positive number. So there's adding a negative number, and that's the same thing as this, 3 minus 2. Subtracting a negative number is equivalent to adding a number. That's with those two negatives here, right? That's the same. This is the same thing as this. And a number and its opposite, like 6 plus a negative 6, add to 0, which is a key idea we're going to use right now. So we're going to solve these 3 equations, and we're going to use the idea of a number and its opposite. In other words, a number and its opposite equals 0. That's one idea we're going to use here. And it's just kind of to show you that algebra really is just a logical extension of arithmetic. So all these we're trying to find out what does the variable, in this case x, which just stands for an unknown number, equal. Well, on this side I'm going to add 8. And if I add 8 to that side, I have to add 8 to this side. So these cancel, right? Because a number and its opposite is 0. So I get x equals 32. Here, you put these two negatives become a positive. So I have y plus 5, so I'm going to subtract 5 from this side and subtract 5 from this side. These will cancel because of this again, and I get y equals 7. Now this is the same thing. I'm going to solve this for y. A negative x is just an unknown number, but it doesn't change in the equation. So what I'm going to do is add x to this side and add x to this side. And I get y equals b plus x. And that was solving for y. This actually is a little bit more to it here than just what meets the eye. With fractions, multiplication is different than addition. Right? And here, you could just multiply 3 times 2 and get 6, and multiply 4 times 2 and get 8. So these two are similar, right? You could also just say this equals 3/4, because any number times 1 is itself. So 3/4 times 2 over 2 equals 3/4 times 1, which equals 3/4. 6/8 and 3/4 are the same number. Now, a lot of students get confused between a problem like this and thinking about it as a problem like this. Which it's not. This is the fraction bar. And this is the division sign. Now they behave the same. They both mean divide, but they are a little bit different. See, in this problem, you have to add the numerators first. And then you add the denominators. And that's the answer. It's 5, 6. It's different than multiplication. You would take, first thing you would have is, and this goes to, remember this, please excuse my dear Aunt Sally, which we're going to explore later in this section. But division is done before addition or subtraction. So if the problem is like this, you would go 2 divided by 4 is 1/2. Then you'd have 3 plus 1/2 plus 2. So you'd have 5 and 1/2. Which is a whole lot different than this. So the important thing to remember here is usually the fraction bar is used a lot, way more than this. And the fraction bar means do the numerator first, then do the denominator, and lastly divide. Like 5 divided by 6 is 5 divided by 6, right? You could turn it into a decimal, but that's not the point. So this one, we're into fractions, subtracting fractions, but we're also going to go back. So this is like 5/4. That's the unit, right? That's what they are. This is 5 of these. And I'm taking away 7 of these. Now, notice the units are not the same. So like cats and dogs, we can't add them. So what we need to do is take the 4 and the 10 and to find a least common multiple or a common denominator, whatever you want to call it. So I'm going to list the multiples here. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. I think that'll do it. 10 times 1, 10 times 2. So 20 is the least common multiple. You know, you could always multiply 4 times 10, And you're going to get a multiple of both numbers. But it's not always the least common multiple. So I'm going to take 5/4, multiply it by a form of 1, and get 20ths. And I'm going to take 7/10, multiply it by a form of 1, and get 20ths. The only thing I can see here is 4 times 5 is 20. So I'm going to multiply it by 5/5. 5/5 is 1. All I'm doing here is taking a number, multiplying it by 1, getting the same number back, but of the form that I want. So that's 25/20ths. So I can just go like this. 25/20ths. Because they're the same number, right? Can't emphasize that enough. That number and that number are the same numbers. So 10 times 2 is 20. So you multiply straight across. And 7 times 2, therefore, is 14. So I can do this. Now, if I have $25 and I take away $14, I'm going to have $11. But in this case, I'm going to have 11/20ths, because 20ths are the unit. You don't add or subtract what it is, right? $3 plus $2 does not equal $5 squared or something ridiculous, right? The units don't change when you add or subtract. So there's the answer. Okay, so in this problem, I'm just going to reduce this fraction. Now, a lot of students will maybe divide the numerator by 2 and divide the denominator by 2, because the 2's, both are even numbers, so they're both divisible by 2 evenly, and get 3/15. And then maybe they recognize that they can also now go ahead and divide by 3 and divide by 3 and get 1/5. And there's nothing wrong with this. Remember, dividing by 2 would be the same thing as multiplying by 1/2. And if you multiply the numerator by 1/2 and the denominator by 1/2, you are really multiplying by 1, which is hard to see. But what I'm going to do here is just do this a little different way. So 6 divided by 30. I'm going to break these into common factors that if I could find any. Like I know this is 3 times 2. And I know that that's 15 times 2. 2/2 is 1. So I can just cancel that. And I'm left with 3/15. And I can find another factor, a common 3. So I can say this is 3 times 1, and this is 3 times 5. That's 1. So I'm left with 1/5. That's the reduced form. There's no other common factors there besides 1. Or I could have done it in one step. 6/30. This is 1 times 6, and this is 5 times 6. 6/6 is 1. They cancel because any number times 1 is itself. And so that's the reduced form. Now, importantly, 6/30ths is the same number as 1/5. They don't look alike, but they're the same. I just showed you. So I'm going to add and subtract these numbers here. And I can't do it because these are thirds, these are 6, these are 12. So I have to find a least common multiple, or some of you might know that as a common denominator. So I noticed the multiples of 3, 3 times 1, 3 times 2, 3 times 3, 3 times 4. So 12 is the multiple of the 3's, and the 6's, 6 times 1, 6 times 2, and then 12. So 12 is my least common multiple. So I have to change 2/3 into 12ths, and I have to change 1/6 into 12ths. Hopefully recognize 3 times 4 is 12. So the 4 goes up here, so that's 8/12. and 6 times 2 is 12, so that's 2 twelfths. So I could swap out 2/3 for 8 twelfths, and 1/6 for 2 twelfths, and minus 5 twelfths. Obviously the twelfths don't change. That's what it is. That's the unit. That's the thing. When I add things, I don't change the unit. 8 plus 2 is 10. 10 minus 5 is 5. So that would be the answer. So I'm going to add these three mixed numbers. And recall, right, that 2 and 5 6 is the same thing as 2 plus 5 6. In the same way, 13 is the same as 10 plus 3, right? It's how numbers are put together. So I'm going to write this all out. 2 plus 5 6 plus 1 plus 7 twelfths plus 3 plus 5 eighths. Now because it's all addition, oh, this is subtract, right? Subtract 1, subtract 7 twelfths. This one here. It's not negative 1 plus 7 twelfths. It's negative 1 minus 7 twelfths. So I'm going to add up all the whole numbers, use the commutative property, right? 2 minus 1 is 1. 1 plus 3 is 4. So that gets rid of this, this, and this. And now I just have to deal with the fractions. So I have 5 6 minus 7 twelfths plus 5 eighths. And I need to find the LCM of 6, 12, and 8. So look at this in terms of multiples. 6 times 1, 6 times 2, 6 times 3, 6 times 4. That's probably it. 12 times 1, 12 times 2, 8 times 1, 8 times 2, 8 times 3. So there is our least common multiple. So I'm going to take 5 6, change it into 24ths. I'm going to take a negative 7 twelfths, change those into negative 24ths, and I'm going to take 3 eighths and change those into 24ths. So 6 times 4 is 24, so that's 20 times 2, right? That's negative 14. And times 3, that's 9. So 5 6 becomes 20 24ths minus 14 24ths plus 9 24ths. That changed all these. So I'm going to add these first, right? Add the positives up. 29 minus 14 is 15 24ths. So there is my answer. And this can be reduced though. So 15 24ths. Common is 3, right? 3 goes into 15 and 3 goes into 24. So this is 3 times 5. And this is 3 times 8. That's 1. So this reduces to 4 and 5 eighths. So we have an equation here involving fractions. But it's no different than involving whole numbers, really. Remember, any number minus itself is 0. So I'm looking at this side of the equation, and that's 7/9. I want to eliminate it, so I will subtract 7/9. But if I subtract 7/9 from there, I need to subtract 7/9 from the other side of the equation. So this is 0. So I get the number I'm looking for. X is just a number, right? Is 5/18 minus 7/9. I cannot subtract these two numbers. They are different units. These are 18ths and these are 9ths. But let's look at the multiples of 9. 9 times 1 is 9. 9 times 2 is 18. So I could just change the 7/9 into 18ths. Some number of 18ths. By multiplying by 1. Now what form of 1? Well, the only information I have, I want 9 to go to 18, so let's multiply that by 2. So then I would multiply that by 2 and get 14/18. So I have 5/18 minus 14/18. Now it's just going to be 18ths, right? $5 minus $14. It's essentially what you're doing. So it's going to be a negative, right? 14 minus 5 is 9. So this is a negative 9, which also is a negative 1/2 if I reduce this fraction. 3 times 3, or 6 times 3, the 3's cancel. 3/6 is the same as 1/2, negative. So the answer is x equals 1/2 to make this equation true. I will put up a full homework, all the answers to all the homework after this is turned in. But just a few things, right? Like here, this is just it's like lose $4 and then lose $4 more 4 times, right? Only instead of dollars, it's x's. X's is the unit. So I'm losing 16 of those. And just a reminder, when you have two negative signs like this, you can cross them out and it's actually positive, because subtracting a negative is the same as adding. Another one here, subtracting a negative is the same as adding. Now this is losing $5 like 4 times, right? And here you're just gonna, it's in algebra, that's a plus, but in algebra it's called combining like terms. You can add all these together because they're all x's, so the unit is the same. Here you're solving for this. Sometimes that's how it's written. So you have to get rid of this by adding this to both sides, and that's all you'll need to do. Same here. Now you'll want to make sure you have thirds, fourths, and 24ths. So you want to make sure you get an LCM here. And the LCM is 24. So you want to change this and this to 24ths. And of course you know how to do that, right? 2/3 is how many 24ths? Multiplied by 8/8, which is another form of 1. So importantly, this is equal to this. And this one here, you'll want to break these up, right? That's 5 plus 1/3 plus 6 plus 2/3, 3/4. So you can add these together and then concentrate on adding these together. And remember, if you get something that's more than 1, you have to regroup. Right? So in other words, if your answer, as an example, is 12 and 6/6, that's actually 13, because this is 12 plus 1. And these should be, again, here you need a common denominator. Here you will add to get x by itself, and then find a common denominator, right? If you add 5/6 to both sides. And that should be easy enough for you.